Hello YouTube. Our universe is full of mysterious and rare minerals, and sometimes meteorites bring these minerals to the Earth, locked as they are inside the space rocks. But there may be more secrets locked in such rocks. I will tell you what I know about a very interesting discovery and very unusual meteorite, but I have to mention that I doubt whether we actually have all the details at hand, and whether all the information has been available outside of narrow scientific circles, maybe even military scientific circles, but I admit that I just do not know. According to the Russians, the first 3 fragments of the meteorite were discovered during the first expedition in 1979 on the Hatyrka River. It was an accidental find in the search for platinum. These fragments finally got to Florence in Italy through traders and smugglers. So what was the meteorite? Hatyrka, in Russian meteorit Hatyrka, is a meteorite found in 2011 in the valley of the Iomrat-Vaam, a tributary of the Hatyrka River, Listvenowy stream, Koryak Mountains, Chukotka Autonomous Okrug district, Russian Far East. It is a CV3 oxidized chondrite meteorite. Chondrite meteorites contain little round structures called chondrules. Chondrules are small spherical structures that distinguish this type of stony meteorite. Chondrules are, in simplest terms, tiny drops of mineral that cooled slowly enough to crystallize. Chondrite meteorites, like all meteorites, have gone through some changes during their long history of traveling in our solar system, in space. The meteorite had fallen in the Iomrat-Vaam River basin and was discovered, or rather rediscovered, during an expedition to Chukotka in July 2011. 9 small pieces were found, each less than 1 millimeter inside, buried in a 7,000-year-old layer of dirt. It was named Hatyrka meteorite. Well, tiny pieces of a chondrite were found during the expedition to Chukotka in the far eastern Russia by scientists from the United States, Russia, and Italy from July 20 to August 7 in the year 2011 in search of the icosahedrite. Members of the team were Steinhardt, Andronicus, Bindi, Disler, Eddy, Kostin, Krechko, McPherson, Steinhardt, and Yudovskaya. The search team removed 1.5 tons of clay and other materials from dense gray-blue clay layers that are exposed along Listvenowy stream and panned it to obtain the heavy fraction within which the meteorite fragments were found. 7 grams were recovered during the 2011 expedition, and an additional 3 grains exist in St. Petersburg, Russia, and Florence, Italy, that were collected during the 1979 expeditions. They are basically microscopic. The minerals in the space rock are microscopic. I believe they're less than 1 millimeter or less in maximum dimension, and the total mass recovered was less than 0.1 gram. The representative fragments were deposited at the Department of Mineral Sciences, NHB-119, National Museum of Natural History, Smithsonian Institution. In 2012, Bindi's group published evidence that natural icosahedrite is extraterrestrial in origin. The assemblage and oxygen isotopic composition are consistent with the formation not on Earth, but in a refractory calcium aluminum bridge inclusion in a CV3 chondritic meteorite. Experts say that quasi crystals look like ordinary crystals on the outside but are totally different from the inside. While atoms in a pure crystal are arranged in constantly repeating patterns, the atomic lattices inside a quasi crystal are arranged in patterns that are described to be ordered and diverse. It displays a range of shapes that has never been witnessed in a natural substance. But there is very interesting information from Russia, and it's fairly recent. Technically, scientists describe quasi crystals as quasi-periodic, manually arranged, which are not in the periodic table, although they show a pattern that continuously fills the entire available mass. They lack what the scientists and mathematicians call translational symmetry. Ufologists and scientists previously assumed that it was in such forms that evidence of extraterrestrial life would be found, pointing out that quasi-crystals, being a new form of matter, should actually be considered as artifacts of artificially created alien technology. However, no one has been able to explain how these quasi-crystals can be formed as a result of natural processes, and hardly anyone would do it. Their forbidden symmetry makes their natural formation impossible. Other well-known quasi-crystals, besides those found in meteorites in the area of the Koryak Mountains, were recently synthesized by scientists in the laboratory. Being very hard with low friction characteristics as well as low thermal conductivity, quasi-crystals are a very useful product used in a wide range of high-speed technologies, such as coatings for aircraft and stealth fighters. A quasi-crystal is a phase of solid matter with symmetries previously thought to be impossible. And then there was this information, okay? In 2016, a small team of researchers from the United States and Italy has found evidence of a naturally formed quasi-crystal in a sample obtained from the Khatyrka meteorite. In their paper published in the journal Scientific Reports, the team describes how they found a quasi-crystal and offer possible explanations on how it was formed. Prior to the 1980s, scientists believed that there were just two types of solids, crystals and amorphous solids. Crystals are materials made of atoms that are joined in a repeated lattice. Amorphous solids are rather the opposite, having no real order. But then researchers discovered that another type of structure could exist, at least theoretically, quasi-crystals. They are made of latticed atoms like crystals, but do not repeat. After establishing their existence, researchers began making them in labs. Over 100 have been created thus far. At the time, it was not clear if quasi-crystals could exist naturally, though some suggested there was no reason for them not to come about under conditions similar to those used in labs. And thus began a search for an example. That search came to fruition, as we know, in 2011, as a team of studying samples from the Khatyrka meteorite in northeastern Russia found two examples of quasi-crystals that were of the same type that had been made in the laboratory. In this new effort, the researchers report that they have found a third quasi-crystal from the same meteorite sample, but this one has never been made artificially before. It is also very similar to one of the other two quasi-crystals found in the meteorite. All three have metallic aluminum, which the team notes bonds well with oxygen. The newest one also has iron and copper. Though they have no way to prove it, the researchers suggest that it is possible that quasi-crystals came about due to a collision between asteroids. Such a violent impact would provide both the heat and energy needed to cause the unique formations. They suggest that further study of the specimens could lead to a better understanding of the early solar system. The discovery also offers a fresh hope that naturally occurring quasi-crystals could be found that originated on Earth. Well, let's look a little more at this. So, quasi-crystals are a recently discovered type of solid matter that use quite different organizing principles for arranging their atoms. They do not have an atomic arrangement which repeats regularly by translation, but they do have rotational symmetry about axis, which can be of crystallographically forbidden orders, such as 5-fold, 8-fold, 10-fold, and 12-fold, as well as the combination of 6 intersecting 5-fold axes that is characteristic of the Platonic dodecahedron and icosahedron. Despite the absence of a straightforward regular repeat unit, they retain a high degree of organization. Quasi-crystalline structures can be made by using more than one type of a building block, which fit together via stringent rules, so that there are no gaps, no overlaps, but also no repetition. There is still enough regularity in the structure that sharp periodicities occur in the diffraction pattern, albeit with a fractal distribution rather than uniform spacing of frequencies. While quasi-crystal diffraction patterns were first obtained from synthetic aluminum manganese alloys by Dan Shechtman in 1982, but early observations were regarded with considerable skepticism even by such eminent crystallographers as Linus Pauling. However, more and more examples were discovered independently by several research teams, and thermodynamic stability in a quasi-crystal alloy was first shown in 1987. Hundreds of synthetic quasi-crystal materials are now known, along with chemically similar approximate compounds in which regular repeating mistakes convert the quasi-crystal atomic arrangement into a normal crystal. Although quasi-crystals can have a well-defined point group crystal class symmetry, they are aperiodic, so other conventional crystallographic concepts such as lattice type, space group, unit cell parameters, and unit cell content do not apply to the structure as normally considered in 3 dimensions. However, it is mathematically possible to generate quasi-crystalline structures by taking 3D slices that are precisely but irrationally oriented to higher dimensional structures that are periodic. The icosahedral symmetry quasi-crystalline structures of icosahedrite can then be described as a carefully chosen slice to a 6-dimensional hypercubic hypercrystal. So, in 2011, Dan Shechtman received the Nobel Prize in Chemistry for his discovery of the first quasi-crystal. The year previously, Luca Bindi's icosahedrite, the first naturally occurring quasi-crystal, was approved as a new mineral by the Commission on New Minerals and Mineral Classification. Icosahedral, named for the icosahedral symmetry of its internal atomic arrangement as observed in its diffraction pattern. In 2017, a team from the Analytical Center for Geological and Planetary Sciences at the California Institute of Technology discovered new minerals in the Hatirka meteorite. Researchers led by mineralogist Chi Ma have identified 3 new minerals in a tiny sample of the Hatirka meteorite. The meteorite, recovered in pieces from the Koryak Mountains in eastern Russia in 1979 and 2011 made news in recent years for containing the first 3 natural quasi-crystals ever found. A quasi-crystal is a phase of solid matter with symmetries previously thought to be impossible. It is the first time in history that researchers are able to prove the existence of quasi-crystals. It was thought to be impossible. A quasi-crystal is actually a phase of solid matter with symmetries. Chi Ma, the director of the Geological and Planetary Sciences Division's analytical facility at Caltech, and his colleagues have discovered 35 new minerals to date, including 32 in meteorite samples. Out of more than 5,000 known minerals approved and catalogued by the International Mineralogical Association, which confirms new minerals, about 430 are from meteorites, meaning that Ma can be credited with discovering roughly 7% of the minerals sourced from meteorites. The new minerals, dubbed stolperite after Edward Stolper, the William Lenhart Professor of Geology and Caltech's provost, Hollisterite in honor of Princeton geologist Lincoln Hollister, and Krachkoite for Valery Krachko, who discovered the original samples of the Hatirka meteorite in 1979. Well, they contribute to the nascent the field of nanomineralogy, the study of rock samples at nanoscales. Nanomineralogy usually uses a technique called high-resolution analytical scanning electron microscopy, in which a beam of high-energy electrons is focused onto a polished sample's surface. Various emitted signals produced from the interaction of the electrons and atoms in a sample allow scientists to observe the mineral down to 1 nanometer resolution and to analyze its chemical composition and crystal structure at a sub-micrometer scale. The newly dubbed stolperite is an alloy of metallic aluminum and copper. Structurally, stolperite is arranged in a cubic form, with each copper atom at the center of a cube, with aluminum atoms at all 8 corners, and likewise each aluminum atom sits at the center of a cube of 8 copper atoms. Normally, we don't observe such aluminum-rich metal in space rocks because the aluminum would have reacted to form aluminum oxide, according to Ma. This means that the likelihood of finding other stolperite samples is low. In fact, the Hatirka meteorite is the only meteorite ever found that contains metallic aluminum. The meteorite fragments hosting the trio of new minerals is now in the holding of the Smithsonian Institution National Museum of Natural History, which maintains a catalog of more than 600,000 specimens. The three new minerals and names have been confirmed by the Commission on New Minerals Nomenclature and Classification of the International Mineralogical Association, which was established in 1959. To name a new mineral, a researcher must demonstrate that its chemical composition and crystal structure make it unique. Scientists continue to examine the space rock and hope to unlock more extraterrestrial minerals. Well, according to various Western and Russian news sites, the director Chi Ma said that normally we don't see such an aluminum-rich metal in space rocks because aluminum would react to form alumina. He said that the Hatirka meteorite is the only meteorite ever found containing metallic aluminum. A meteorite fragment containing a trio of new minerals is, okay, we already said that it's in the collection of the Smithsonian. The head of the Institute of Astronomy of the Russian Academy of Science, Boris Shustov, said it's common to find new minerals and meteorites as they form under conditions different than those on Earth. This is a fairly common phenomenon due to the fact that a number of minerals and substances that can be formed and are formed under cosmic conditions are not found on Earth, he said. Well, if this material had not been created by nature, as some claim, well, where did this mysterious material come from, and how did this complex material end up inside an ancient meteorite? Could the extraterrestrial material found in the Khatyrka meteorite have been artificially created millions or billions of years ago by an ancient civilization from another world? Was it part of a much more complex technological structure? Well, it was found in Chukotka. I urge you to look at my videos about Chukotka and Kamchatka. You will find them in the playlists, and it's an incredible territory with so many mysteries. I know we keep our eyes on Area 51 and Roswell and so forth, but trust me, the world is much larger than that. I've seen it in Africa, in Mexico, in my native Soviet Union, and it's incredible. You cannot limit yourself to just what is found in the United States, although that in itself is amazing, but there is a whole wide world out there. So Chukotka, far away and cold, but even in the most northeastern region of Russia, they have a south. Well, the south of Chukotka is Khatyrka. Everyone knows about Khatyrka in Chukotka. Khatyrka is close to Kamchatka, which is only 40 kilometers away. And then there is the Koryakia, the mountainous country. The Koryak upland begins 100 kilometers south of Anadyr. And to get to Khatyrka, you will have to travel along and across this country for 300 kilometers. And Anadyr has had its own UFO history. You will see it in my other videos. Now, Khatyrka is a small rural locality, selo as we say in Russian, in the Anadyrsky district of the Chukotka Autonomous Okrug, or region, in Russia, located on the shore of the Bering Sea, southwest of Berengovsky. The Chukchi call this place Vaterkan, meaning dry or exhausted, as the area surrounding the village is used for reindeer grazing. Look, you need to acquaint yourself with Chukotka, because the UFO experiences I have collected from that part of Russia are really incredible, and the strange clouds and much more. But also I attached something else to this video. Look at the YouTube video that shows a very interesting event. In 2020, a biologist in Chukotka filmed an unusual object in the sky. An unidentified flying object was filmed in the sky, which fell from the height with a cloud of smoke that the object did. Well, the scientists, he noted that the falling smoking object does not look like a downed plane. Well, the subscribers to the channel in the comments began to assume that what exactly burned in the atmosphere was probably a rocket or a meteorite. Could be more things that are falling down from the sky or observed in the sky over Chukotka. And I will bring you more videos on the subject in the future. If you like my research, please support me. You will find description on how to do it in the description to this video. Please like my channel, please tell others, please subscribe. Thank you.